Hello, hello, hello. Yeah, so my stream ended midway and I didn't realize it. But now I see that it has ended 43 minutes ago. So I guess I was here, somewhere here, all right, and I was pasting some engine.rs files. Yeah, well, we did paste it and we moved on. So what I'll do right now, I'll just show you the overviews. I'll give you the tree, like what happened and what not happened. This was our last result that we got. We got motion energy, variance, and all that. And we'll move on from this project. All right. This project, our aim has been achieved. We know how to, combine a Rust project with a Python one. We know how to create a Python UI and just everything in Rust. So why this one is important, because earlier we were remember that we calculated RSSI, or we sort of gathered RSSI, and we gathered using Python's loop, and Python loops we know is heavy and sort of all that reasons. So in this project we created it in Rust only. So this is our engine.rs. If you want to see it, just see it. And yeah, this is the same. And there has been some changes later on, but yeah, mostly it is this. We want to change this as features.motion, and then we want to add a feature called motion, and we want something like motion, then energy and variance, the whole three datas. Uh, I did not make the change because I sort of realized my live stream ended. And this is lib.rs. I know we created lib.rs, exactly this. This is controlling it, and we changed we changed the 256 to 128, because 256 is like waiting for 25 seconds to things to happen. So we changed that to 128 or something like that, so that we don't have to wait 25 seconds. We just have to wait we just have to wait 6 seconds or something like that, or 12. I don't know. Yeah. So this command is used for recompilation. So we just created engine.rs and lib.rs, and then we sort of ran run.engine.py. And see, we only passed the device name and the loop was running in Rust. So that's why it was fast. So this said I should get some output like this, and what we have built and all that. But I guess we had some problem. Or no problem. For now, motion energy is this, and I was not able to like close it. So yeah, I was pressing Control C, Control X, Control Z, everything. So Control Z ended this program. All right. So great. This engine runs correctly. Your log shows the data. It says, yeah, it's working great. Now this happens because now it's trying to explain it, that there is some error, like, buffers and all that, because I guessed that motion energy was damn too heavy, like this much of a data, like it's in a million, like 19,980,000, something like that. So yeah, we sort of reduced our motion energy to something where we are in thousands or hundred thousands, like 1,500,000s, isn't it? 150,000 and 662, something like that. So that's what we came towards. So fixes that we fixed our features.rs. We go to feature.rs and replace the whole code with this program. If you want to type it, just use this as a reference. Key change was that we, took out something like average, and we still did not add features motion. All right. It tells us at the end, but we won't do it. Like I won't do it. If you want to, you can. So this is fix 2, and find this line and change it or replace it with this. What's changing? Just the windows. Otherwise, we were sending signal directly to the buffer. But now not butter, but buffer. What's happening? So earlier, what happened? Like I remember the code. What happened? I'll explain it to you over here only, so that you don't have to be confused. We had a signal, and we did not have this line. All right, so we directly send the signal into the butter, and then send the butter forward. So what we are actually changing is we are adding this windows, which is taking the signal, and then we are sending the window into the butter. which is Butterworth. All right. So this is the net change that I think happened. Then we have to recompile it and then run again. So we run and it expected something like this. But I think we got something like 0 0 0s. Yeah, we got something like 0 0 0s. And this is also an error. So it said good catch. And then it tried explaining why this happened. And then the fix was that go into buffer and replace the buffer with this. So we replaced this whole buffer with this, a new buffer.rs. And then fix 2 was that go to engine.rsi and find this section, which is, self.buffer.push RSI, then signal, we are getting signal. We added a if condition. That's it. That's the change in engine.rs. That's it. Now we recompile it again and we try running it, and it is still expecting something like this. And we gave it some output, which is, I guess, some errors, isn't it? Yeah, it was giving me nothing. So I had to close that. So I had to press Control C because it was not giving me anything. So I thought, what's happening? So it told me to wait for 25 seconds. Then we waited for 25 seconds and then things started happening. So yeah. So from sleep, the sequence is roughly read RSI and all that. So it's explaining right now. Quick verification, it told me to wait for 30 seconds. And as I waited, well, I got a result suddenly. So I didn't have to close it. And this was the result, which is in 100,000s, like very near. But see something from the output that every value is nearly same. Like these are same and these are same. So now it got something like, yeah, this is a real bug. And now it tried solving it. So the new fix was go to buffer.rs and then replace the snapshot function with this snapshot function. So what happened was snapshot function was nearly 3 lines, and now we have a snapshot function which is, I don't know, 7 to 8 lines. Now this fix mattered, and it is trying to explain why this fix matters. Well, I don't care about this project now. I'm done with this project. So I'm just giving you a summary of what happened after the stream sort of ended unexpectedly. Then we recompile it again. We ran the run engine.py again, and that's it. It is again expecting something like this. And small improvement is that in engine.rs, instead of 256, we can do 128, so that our waiting time will become 12 seconds. Yeah, instead of 25 seconds. This is not in engine.rs, so this is its mistake. So this is something I found in not in engine.rs. There is no engine.rs, and you can change the value. I found this in lib.rs. All right. So I changed it to 128. Let me show you. So let's go to engine.rs. Oh no, first we have to go in src, then engine.rs. See, there is no engine and new, engine new, or let's search for a value of 256. 256. There is no value of 256. Let's search for a value of 256. Yeah, there is no value for 256. There is nothing as engine and then new. See, nothing like that. I thought, what is this? What is happening? So I see a function which is sort of not a function but implementation of engine. We see a method which is new. So that's what we are trying to call, and we see a size. So size is a variable. We are not mentioning it in engine.rs. So I sort of started seeing where am I mentioning this size variable, where am I using the size variable. So I didn't see any size variable in here. Where did I see that? I went to let's go to src lib.rs. So I see over here the same line engine new, which is using engine and method new, and then we are sending the interface, which is somewhere from here, interface. All right, then we are sending 128 seconds. So this is where I changed it from. It was 6, I changed it to 128. That's it. So where are we now? This is its chart. Where are we now? Next step, it's telling me to do these things. Well, yeah, this is, I guess, my last output. Yeah, exactly. This is my last output. And this is where I ended it. But now it's telling me instead of just motion energy and variance, I should check three things like motion, energy, and variance. So it tells me to normalize or a feature. So go to feature, use this function energy, and then this will shrink the value of something like energy to 2.3 and variance to 1.1. Sorry, like instead of hundreds and thousands, we'll get into this. So I have not implemented this. Let's go and implement this, but let's see this, what is doing. So step two was, go to public, go to features and make a public motion, all right, which is of type F64. And then compute something like motion, what is the motion, and return something like features, which is variance, energy, and motion. And motion is nothing but square root of variance. So that is our motion. And in step three, we sort of updated our engine print. So in engine.rs, we go to print statement, and instead of this print statement, we give it this print statement. All right. That's it. It tells us to recompile it and blah, blah, blah. Shall we do it? Well, I think I will do it because, this is our last output, and then we did some changes. That's it. So let's make some changes, and this will be our last changes, and we'll get back to our Rust book because we have less time left, and I don't think I will be able to complete the Rust book. So we'll end it wherever we can. So let's go to features.rs, vim src, and features.rs. Inside that, it tells me to sort of replace the energy section with this. So there is an energy section. I don't see any energy section. Yeah, this is the energy section. So it tells me to replace the energy section, which is this, with this. So energy will become, instead of this, come up here. I'll just GC say it instead of just removing it. I'll get to the end of it. I'll append and take a new line. Over here, I'll paste this energy section, which will just shorten it out. Instead of getting in hundreds and thousands, we'll get a short energy section. That's what it is expecting. I hope this stream will not end like it did earlier. So yeah, this is our energy section now. And what's next? Well, I don't care about these indentation because this is not Python, this is Rust. Step two is, in features struct, add this structure, which is public motion F64. That's it. And then compute the variance square root. So over here, it's telling me to go over here. Yeah, see, sort of automatically did it. So it's telling me to go over here, take a new line, paste this, which is a new public features. And then we have to compute motion with a variance root. And we have to also return that from features. Just copy it. Well, my PC was hanging down too much. So we have a variance over here. So below that, we'll paste motion. And then over here, instead of just returning variance energy, we'll also return motion, isn't it? Variance energy, and we'll also return motion. That's it. And the step three was go to engine.rs. So our work is done over here. We go, yeah, everything is same as it should be. It tells us to go to engine.rs and replace the print statement. So we'll go to src engine.rs and we'll, well, where is the print statement? First of all, let's see where's the print. Yeah, over here. So this is our print statement and we have to replace this. Well, let's not replace anything. Let's just add things to it. So features, energy, features, variance, and before them, we have to add features. Yeah, insert. You have to say phi a tures dot motion, comma, features energy is there. All right. So I think this is done. Just change the print statement, which is something like this. Uh, right. Add again bracket uh, dot three. That's what we do. 333. So we have motion, we have energy, we have variance, and we want three floating digits. So like decimal up to three digits. Replace this with three and replace this with three. So I don't think there is much of a difference with this implementation of ours and this implementation of this one. I don't see any differences. Features motion, features energy. I don't think there is any typo also. Features variance. Now it tells us to recompile it. We will recompile it. We are in Rust engine only, so we don't want to change anything. We just have to say mature develop release. Let's do it. Mature uh, developer dev, isn't it? No, develop develop. Well, there is no tab completion. I am pressing tab and nothing's happening. So yeah, that's a bummer. Now mature develop and release. release. No typos there also. Oh, we are recompiling it. It will take most of our CPUs. See. Hmm. I hope this time this stream doesn't end because earlier, well, it's irritating when the stream ends suddenly. I also thought, like, why not change the whole name and thumbnail for the previous stream that we did? So, yeah, it has compiled. It will tell us to sort of run Python exactly. So, we'll go back, we'll do, Python, and we'll try running Python and run, not why. We have to wait for, I guess, 12 seconds. 1, 2, 3, 4. Well, my counting is not important. What's important is running it. Yeah, see? So instead of getting it in hundreds of thousands, we are getting motion in 298, energy in, well, just thousands, uh, and variance in thousands. So good. Great, actually. So exactly, not like this, but somewhere near. And where the project stands now is this step. Now this will allow a real dashboard. Next step is, much cooler, creating a dashboard like thing. Well, I think everything is done. Now, one more improvement is right now the engine does something like iwdev volen link, which spawns a new process every 100 milliseconds. This is extremely inefficient. Later, we can replace this with a netlink polling, which is how Linux Wi-Fi tools actually read RSSI. All right, that alone will make the engine 15 times more efficient. All right, so instead of doing this like a Python style, we will implement it like Linux style, like Linux Wi-Fi tools. Oh, I'll not make any changes. This is for next time. And then I said, create something like this. Well, now this is a great thumbnail. I'll change, you know, well, I think I'll change the title of it too and description. Otherwise, it's just generic title and description. We'll call Wi-Fi. And instead of in documentation, we'll say it in downloads, right? Channel content, here. It was live, I guess 13 or what? Yeah, so this is live right now. This is my stream right now exactly. I want to edit this one. Uh, what will I edit? Uh, part 14. Well, should I let it remain like this and just change the thumbnail? Change to what? Downloads and something like Wi-Fi. Yeah. Oh, it's greater than 2.2 MB. Shit. Now I have to compress it and all that. This is YouTube's, well, policy. All right, I will do it in my own time. I think I will just, change the title to a special. All right, just special. SPECIAL, special side project. JECT. Let's create the full project. All right. So this is the changed name now, but this will be a part 14. All right. Not much changed. It actually took this thumbnail. So this is now thumbnail. It's our previous one. A/B testing. Let's do this. If you know what A/B testing is, good for you. If you don't, it's still good for you. Live Rust. This one, no? So we'll have a two thumbnail to check which one works, which one doesn't. And after uploading, set to the test. We have two thumbnails for this same video and we'll save it. I don't know why I'm doing this while I'm live. So yeah, it will take the change, get back to ChatGPT, and I think we are done. All right. I think we are done. We'll start with a Rust. Why is it hanged? Damn. Yeah, this was a thumbnail. Let's give it a new outputs and move on. Not describe edits, not this one, dummy. I think we do not copy our output this time. So this is our latest output. That's what I want to tell you. Well, it is hanging. That's what happens most of the times. We have to cope up with it. Nothing we can change. Nice. That output is exactly a proof of work result that makes a good demo video title description. So, well, these are my video titles that is suggested now after hanging so much. And this is my, well, thumbnail. If you want, I can give you tags. I don't want. Thank you. Let's close it. All right. Let's get back to our Oh, there are two views. Well, for me, somebody just came and went. Or is it just me? Widget, the stream current bit rate is kbps is lower than recommended bit. We recommend you use stream bit rate of 6800 kbps. What is it right now? Oh, so it is low. And it is telling me to, increase it. We'll do that, sir. We'll do that later on. But let's now continue with our lifetime. Isn't this where we left off yesterday? So yeah, lifetime. This is exactly where we left off. So this is in scoping rules, lifetime. This is the, bigger program. And we are still learning Rust. So let's go. Rust, by example, lifetimes. So a lifetime is a construct, the compiler. So a lifetime is a construct the compiler. It sounds like a broken English, but all right. A lifetime is a construct the compiler, or more specifically, its borrow checker uses to ensure all borrows are valid. Specifically, a variable's lifetime begins when it is created and ends when it is destroyed. While lifetimes and scopes are often referred to together, they are not the same. Take, for example, the case where we borrow a variable via ampersand. The borrow has a lifetime that is determined by whether it is declared. As a result, the borrow is valid as long as it ends before the lender is destroyed. I think something has happened to me. That's why it's like I am buffering in real time. So lambda is destroyed. So let's read it again. Take, for example, the case where we borrow a variable via ampersand. Yeah. The borrow has a lifetime that is determined by where is it declared. As a result, the borrow is valid as long as it ends before the lender is destroyed. All right. However, the scope of the borrow is determined by where the reference is used. However, the scope of the borrow is determined by where the reference is used. In the following example, and in the rest of this section, we will see how lifetime relate to scopes, as well as how the two differ. Let's see. Run this. There are two print statements, so we should see some drama. Yeah, borrow 1 is 3, borrow 2 is again 3, and we are borrowing I guess. And we can borrow till this I lives. If it doesn't live, we can't borrow it. We know that. Lifetimes are annotated below with the lines denoting the creation and destruction of each variable. So I is created over here and gets destroyed after the scope ends of the main, because we have created I in a main. All right. So I has the longest lifetime because its scope entirely encloses both borrow 1 and borrow 2. So the duration of borrow 1 compared to borrow 2 is irrelevant since they are disjoint. Yeah, borrow 1 is in this small scope, which is inner scope, and borrow 2 is in this inner scope. So first borrow 1 comes and then dies. Like this is its lifetime, borrows 1 lifetime, and this is borrow 2's lifetime. So yeah. Note that no names or types are assigned to label lifetime. Yeah, not for now. This restricts how lifetime will be able to be used, as we will see. Okay, let me see. So explicit notation. Yeah, this thing is explicit notation. So this tells us for as long as this a, which is dependent variable, lives long, we can do this. Otherwise, well, lifetime has ended, so we can't do this. So this is now explicit annotation. Now the borrow checker uses explicit lifetime annotation to determine how long the reference should be valid in case where the lifetime are not valid. Is this a word? Well, if you want, you can take me to this word. What is this word? Oh, elision is implicitly annotated lifetime, so it's different. Elision is different. Elision is this, whereas, where are we? Elided was this. What does elided means? Let's ask this brave. What does elided means over HERE? Elided, isn't it? Where is it? Elided. In case where lifetimes are not elided, what does that mean? In this context, elided means implicitly omitted or inferred. So if it's not implicitly, like internally omitted or inferred, Rust requires explicit annotation. All right, so if it's not implicitly inferred or declared or either omitted, then Rust requires explicit annotation. All right, to determine what the lifetime of a reference should be. The syntax for explicitly annotating a lifetime uses an apostrophe characters as follows. So there's a foo with lifetime dependent on a. So foo has a lifetime parameter, this a, and this is not a, this is, can we call it an apostrophe or a single quote? Well, since this is not quoting it, so it's just apostrophe. So it says, for example, over here in this AI, you don't have to write them explicitly. For example, something like this. So gives the same example. Just there's some implementation for a, just x, and we are again taking a reference of string, but it is with a lifetime a. Exactly, and will give us a return value of lifetime dependent on a. All right, let's close this and see what's next. So similar to closures, yeah, the function, shorthand function, that's what I call it, shorthand function, because it acts like a function, but it is not, but it is not. So yeah, confusing, but works. So similar to closure, we use pipes, pipes to indicate that this is closure. Not just indicate, use the closure. So closure has a format that uses pipes, and inside those pipes, we use it like a function instead of brackets. So similar to closure, using lifetimes require generics, all right? And additionally, this lifetime syntax indicates that the lifetime of foo may not exceed that of a. Exactly. Now, explicit annotation of a type has the form of ampersand a and generic t. Like it can be string, it can be character, it can be anything. Now we are taking a reference of it, so ampersand. Where the this a has already been introduced, that it is lifetime parameter. In cases with multiple lifetimes, the syntax is very similar, but we just have to pass two lifetimes. So it is dependent on a and b. So if either one of them goes out, well, this function falls apart. So the foo, and it is dependent on lifetime of b and lifetime of a. So foo has a lifetime parameter that is a and b. In this case, the lifetime of foo cannot exceed either a or b. Yeah. The following example of explicit lifetime annotation in use. So we have an example and we move on. So let's first of all read this example. So we have three comments, which is saying, print ref, which is this function, takes two references of i32. Yeah, x and y, which is two different references of i32, which have different lifetime, which is a and b, exactly as I see. B, and this is one a, and we are defining it has two lifetime parameters, that is a and b. Now those lifetimes must both be at least as long as the function printf. Yeah, otherwise this printf would not work at all. And we are just printing the x and y. And we'll call this function printf in main, but for now, let's see the next function. So a function which takes no argument. So this is a failed borrow function, but has a lifetime parameter dependent on a. Still, it does not take any argument, but still it is dependent on a, because I don't know why. But failed borrow is something like let x is equals to 12. Now error is that x does not live long enough. So the y and is dependent on lifetime of a, and it has a value of x, which is again 12, and they are unused variable. That's why we used underscore before them. So yeah, Now, attempting to use a lifetime of a as an explicit type annotation inside the function will fail because the lifetime of x is shorter than that of y. A short lifetime cannot be coerced into a longer one. All right. Now in function main, we have let 4 and 9. We have this, tuple. Inside that we have 4 and 9 element. So 4 takes the reference to 4, 9 takes the reference to 9. We pass it by reference 9 and 4 in the printfs, and which borrows ampersand of both variables are passed into the function. Yeah, and then any input which is borrowed must outlive the borrower. So this has been sort of borrowed, so it must outlive the borrower. So this 4 and 9 outlives the printf, which is the borrower in this case. That means the 4 and 9 must be longer than that of printfs. Yeah. Whereas the failed borrow is sort of, failed borrow contains no reference to force the lifetime of a. Like, what is this? Which is the factor it is depending on? It is depending on nothing. So that's why, even if it try forcing it to a lifetime, it has nothing. So 2 will longer than the lifetime of a function, but a is a longer because the lifetime is never constrained. It defaults to a static. Let's run it. If we see any errors, we shouldn't. Well, we see some errors. Let's not run it. Let's just run printfs. We still see errors. Why? So it is error because of x does not live long enough underscore x, and it says that failed borrow has a lifetime of a defined here, and then what? The winding x a declared over here. All right, and then y is borrowed value does not live long enough. So x does not live long enough, so we cannot borrow it. So type annotation requires that x is borrowed for the lifetime of a, but x is dropped here while it's still borrowed, so that causes the error. So what can we do to resolve it? Well, I just did not call this function, but still won't let me go. I have to think, I guess, remove this. Just remove this and remove this. Yes. Yeah. Now that works. Because this is now not working at all. We are not dependent on any sort of lifetime. Whereas this one is. So I think we should move on. And as for elision, well, this is opened up over here. So elision, we have not seen. Where will we see it? Let's see. So we'll see in lifetime only, but at the last sort of section, which we might not cover it in this sort of stream. Now function. So lifetime of functions. That's what we are talking about right now. Let's see. So ignoring the elision, which is, I think I have to read the elision a little bit, but what it means. So elision, some lifetime patterns are overwhelmingly common, and so the borrow checkers will allow you to omit them to save typing and to improve readability. This is known as elision. Elision exists in Rust solely because the pattern are common. So the following code shows a few examples of elision, and for a more comprehensive description of elision, see the lifetime elision in books. Let's see. So this is lifetime elision in Rust programming language, which is more comprehensive than what we are reading right now. The struct definition, this is lifetime elision, and that's what we want to read, not the whole section, but we can. We'll read few lines and we'll move on. So it says you have learned that every reference has a lifetime and that you need to specify lifetime parameters for function or structs that uses a reference. However, we had a function in listing 49 shown again, which is this one, I guess, in listing 10 to 25 that compiled without lifetime annotation. So there's a function first word which has a ampersand str taking s, and it returns ampersand str. We have a bytes which is s as a bytes. We represent s as a bytes, convert them to bytes, and then what we do, we take I and ampersand item in for loop of bytes dot iter dot enumeration. So for each bytes we enumerate over it. We say if item is equals to b, we return the whole reference of s from 0 to I, you know, this way. And then we return the whole reference of s. What does this do? No output, because we are not working with this first. Yeah, we are not calling the first word on anything. Or we are calling it over here. I think it's still not working. Why? I don't know. Because we are not printing it. Yeah, exactly. We have word, but we are not printing it. So yeah, there's no print statement to see what we are doing actually. Let's go back. Let's see the function. So ignoring illusion, the function signatures with lifetime have few constraints. The function signatures with lifetime have few constraints. So any reference must have annotated lifetime. Any reference being returned must have the same lifetime as an input or be static. Additionally, note that the returning references without input is banned if it would result in returning references to invalid data. So returning references without input is banned. We can't return reference without taking an input if it would result in returning reference to invalid data. All right. The following example shows of some valid forms of function with lifetimes. So we create a function that is called print1. It has a lifetime based on a, and that a is lifetime of whatever reference we are taking of i32. Its lifetime is a, and we are taking that as x in this function, and we are trying to print 1, and x is, we are trying to print the value of x, whatever it is, i32 or reference of it. So it says one input reference with a lifetime a which must live at least as long as the function. All right, it will. I think so. The mutable references are possible with lifetimes as well. It says we have a function add1 which is again has a lifetime dependent on the lifetime of this mutable x references, and we are adding the x with 1. So we are appending the value 1. So this is add1. This will mutate the variable data. Then we have a print multi. Instead of print 1, we have print multi, which depends on lifetime of 2 sort of variables. So a and b. Now they both are a reference of different numbers, and they are taken as x and y, and we are then printing those x and y. It says multiple elements with different lifetimes. In this case, it would be fine for both to have the same lifetime, that is a, but in more complex cases, different lifetimes may be required. All right. Returning references that have been passed is acceptable. So however, the correct lifetime must be returned. So we have a and b, again the same thing, and we are returning the return based on a lifetime of a, not b, just a. It says returning the references that have been passed in is acceptable. However, the correct lifetime must be returned. All right, and we are just returning x, which is this. So whatever the b is, it is not used, so it dies, I guess. That's why we are not using b, a lifetime of b. We'll try seeing if there's any error if we use that b. All right. Now we have a function invalid output. which takes the input of lifetime of a, but we are not passing any sort of input, and then we are returning a value that is ampersand string with a lifetime of a. But what this lifetime of a is, nobody knows. And then inside this function, what we are doing is string from, and then we are returning to sort of, yeah. Now the above is invalid. Why? Because a must live longer than the function, whereas it is not. Here because as soon as this invalid output, sorry, yeah, the function name is invalid output. As soon as it ends, this a sort of ends. So you can't have a return value which sort of gets ended before you can even use this lifetime to return something. So that's why it is invalid. So here this ampersand string from foo would create a string followed by a reference. Then the data is dropped upon exiting the scope. That's what happens. And leaving a reference to invalid data to be returned. Leaving a reference to an invalid data to be returned. So it would just return an invalid data or reference to it. So that's a dangling pointer, I guess. So that's not valid in Rust. So that's why this whole thing is invalid. Now in main, we have a x, which is 7. We have a y, which is 9. We are sending x's reference in print 1, which just prints the x. It takes the x, it prints x. In y, in multi, print multi, we print both of them. All right. Then we have a z. Inside that, we pass x, which is x and y both. Over here, but y doesn't matter, and we'll try doing it b over here. That's what we want to do. Then we are printing 1, which is z. So whatever the z is, which is the value of x, we are printing that again over here using printing 1. So it's like sending ampersand of x, but we are sending z, which is again the same, because the return value is x only from this pass function, pass x function. All right, then we have a mutable t, which is equal to 3, and then we use add 1 on it, where we send the reference of mutable t, and then we again print the t, which is again x, which is 3, but it is plus 1, so it is 4, so we print 4. Let's see. So yeah, the first one is sort of x, which is 7, good. Second one, which is 7 and 9, good. The third one is print 1, which is printing again the first x, so x. And then over here we have a 3, we add 1 to it, so mutable t adds 1 to it, which because there's a function add 1, this one, it adds 1 to it, and then we are printing the t or reference of t, which is 4, exactly as we expected. So I guess we can move on now. Oh no, I wanted to experiment something, some sort of errors, if I may say. Instead of pass x, we give it a reference of b, which does not live long enough, I guess. Yeah. So it says lifetime may not live long enough, may not. Does not know if it does, it doesn't. It says may not, because we are not even using it with a variable. Like it is not used in this function at all. So that's why the b lifetime might not even live long enough. So we should give it a lifetime of a instead of b. Now it runs fantastically. So we saw some sort of error that we wanted to, and now we are on methods. So methods are annotated similarly to a function. And what are methods? Methods are function, but they are in implication blocks, which is implementation of owner. Inside that we have function, but these are not function, these are methods, which are because they are defined into a structure, which is sort of owner. So owner has something like owner, then colon add 1, or over here we use dot. I don't know, sometimes we use colon if we divide it into crates and all that. Sometimes if we just print it using main, use dot. So it is confusing because I don't know what's happening right now with dots and colons and all these things, but it'll be clear soon enough. So this owner, which is structure, which takes ith2, has two methods, which is add 1 and print. So add 1 takes the lifetime of a, which is ampersand a mutable self, takes the self, adds 1 to it, That's it. It doesn't print anything. In print, it takes again the reference or lifetime of A. It takes the reference of self and it prints the element, which was whatever it passed plus one, whatever it was, then printed. So we send 18 to it and we'll print 19. So owner is first of all 18. Then we say add one, it becomes 19. Then we say print, it prints 19. So if we run it, we'll get 19. Run it, don't time out. Yeah, so print is 19. See, as expected. So methods work the same, but what I don't know is why do we sometimes use dot or sometimes we use colon like this. I don't know this thing, why that happens. You know, uses unresolved modules. So yeah, I was guessing right. It was related to crate and all that. It says in line 15, instead of doing this, use big O. It thinks there's another owner that is starting with big O. So that's why it's trying. But the reference of owner is missing. Owner is missing. So it's trying or suggesting me something, but I don't know what it is. So I'll just move backwards with a dot and it works. It works. Let's move on. Now we are at structs. So I guess I am moving very quickly and we have, done 4 modules. We are on 4th. We still have 5 left to go. So yeah, so struct. Like I was checking my live stream if it sort of ended or not because earlier today it ended unexpectedly. That's why I have to be cautious again so that it doesn't happen again. Right. Now structs. So annotation of a lifetime in structures are also similar to function. All right. So we have a type borrowed which houses a reference to an I32. The reference to I32 must outlive the borrowed. So we say derive debug to print it using derive, question mark and all that. Struct, which is a structure borrowed, has a lifetime of A, and we are sending it a reference of I32, which has a lifetime of A. Again, this is our structure. We have another structure. Similarly, both references have must here must outlive this structure. So we have only one lifetime. So yeah, it will. So we have again a named borrow, which is taking a lifetime of A. And then in X, we are using the reference of the same number. So X and Y are the same number. All right, there's no different. There's no difference at all. Then we have another, well, enum, which is like structure, but different. Enum, it sort of is a close possibility. Like there cannot be another possibility in enum. Like let's say if you are opening a door, so you say something like we create a door. So we'll say something like enum door, and there can be only two possibilities: either door is closed or door is open. Well, think clearly because there can be other possibilities too. Door can be in the phase of opening also, door can be in the phase of closing also. So enum should have the 4 things like door closed, door opened, door is closing, door is opening. All right. So enum sort of comprises all the possibilities that could be existing. Whereas in a struct, we are just creating something like structure. Enum is like creates the structure, but also it should be closed structure. Like there cannot be any other possibilities outside of that structure. So that's enum, I guess. That's what I learned. If there's any mistakes, well, please rectify me if you know. Now derive debug is there, and we have enum, then either, it has the lifetime of a, then we have num, and then reference of that. So num is I32, and then reference of it is like ampersand, depending on that where reference and I32. So lifetime is there as apostrophe a. Now in main function, we have x and y, 18 and 15 respectively. And the single is sort of variable where we say borrowed and we send a reference of x. What does borrow do? Well, it creates a structure. Single is now a structure with a reference of x. All right. What's next? We have named borrowed, which is this, which, takes the whole reference of x and y. Both of them are different numbers. I thought they were same numbers, but they're not. They are different numbers. So x is 18, y is 15. I was wrong over here. I thought x and y would be same number. It is not. They're of same type, but numbers are different. All right. So they're of type I32, I32 respectively with a lifetime of a, but numbers are different. Numbers are 18 and 15 respectively. And the let reference is equals to either ref. So either, and then we are passing the reference to it, which is ampersand of x. So it is a reference of x. As for the number, we are passing y. So number is y, whereas the reference to that number is just the reference to another number, which is x. I don't know why are we doing this. All right. Then we have a print statements, 4 print statements. So print will do what? Print will print the x, which is 18. Well, a structure. All right, not just 18. It will create a structure with 18 in it. And then named borrow will do the same, but with x, which is 18, and y, which is 15. Either ref will, well, give us a structure with either ref, which will be a reference to the ampersand x, 18, and the num will be just y, which is 15. Let's try running it and let's see the results. So y is not borrowed in num, and we say num is 15. All right, so number is y, which was 15, whereas the reference that we took was for x. So the reference is x over here. Yeah, exactly. As for doubles, we get x is 18 and y is 15 as named borrowed. Exactly, that's what we expected. And then as for borrowed, we get 18, exactly as we expected. So let's move on from structs also. Now traits. So our traits, we define a struct, we define implementation for that struct, and that's it. I don't see any traits. Where's the trait? Damn. Do I even know what the trait is? I know what the trait is, but there's no keyword trait used over here. I don't know why. We used implementation, which I guess is a trait for the borrowed structure, but that's what I call implementation of that structure, not trait of that structure. But what is the difference between implementation of that structure and trait of that structure? Let's search. In the given code, what's the difference between the implementation of the structure and the what? And the trait of the same strucui. Many typos are there, but let's see what it comes up with. The difference between the implementation of a structure and the trait of the same structure lies in their purpose and scope. So if we say structure implementation is IMPL, this is where you define the method specific to the particular structure. Yeah, exactly. Like new, open, close, something like that. It allows you to add behavior directly to the structure, and you can use the lifetime annotation here to specify how references behave within the methods. As for trait implementation, a trait defines a set of methods. So trait does the same, like defines the set of methods, but not as implementation, but just like a trait. That can be shared across multiple types. Sorry. So that can be shared across multiple types. And when you implement a trait for a structure, you are ensuring that the structure supports these methods, and the lifetime annotation in the traits are similar to those function, and that define how the references. In short, implementation is about defining how the behavior. In this code, I don't see any trait. Like I'll say that in this code, I don't, huh, don't see any trait. Can you? Like there is implementation. I don't think there's a trait, but it says something. Like, great question. There is a trait in this code. It's just not immediately obvious. So the trait being implemented here is the default trait. So which one? Big one default or the small one default? I think this default it's talking about. So yeah, let's break down. So implementation of A is there, which is like lifetime, and the default for borrowed, which is again the structure which is borrowed with a lifetime A. This line says the implement default trait for the borrowed structure. All right, so we are implementing the trait, not just defining a trait. We are implementing a trait directly without defining it. All right. So we are implementing a default trait for borrowed with a lifetime of A. Good. Now default is built in Rust trait that requires you to define a default method. So we are defining a default method which returns self, and we have then self, which returns x, which is a reference of 10. Method which returns an instance of the type with different values. So the structure of this code is something like borrowed A, the structure being defined, and the component which is default. So the trait being implemented. Now component over here, which is implement A default for borrowed a trait implementation for the structure, and component which is the method, I guess, the required method from the default trait. Exactly. So default, this is the method for the default trait. In this example, you are telling Rust when someone calls the default like this. Exactly. See, double colons. I don't know why. Did they use double colons? Exactly. They use double colons. Sometimes they use single full stop. So tough. Like over here, they did what? They used double colon. Whereas here, they used single dots. So owner is there, and we are directly implementing owner. Like we are not implementing add one for owner. So add one would become something like a trait, but we are not defining a trait as add one. We just want a method as add one inside the owner structure. But then we are saying owner is this and that. We are giving it the structure as variable owner. And then we are from variable, we are accessing the method for the owner. And if we just try to print the owner, can we do that? Can we edit this to something that we want? Like in a square brackets, we say derive, and in this we say debug. This will work. It works. So I just, instead of printing or accessing these methods, well, how about we do that, but still we try printing, print ln. This is a macro, and inside that, first of all, use this, and inside this we give it just the owner, which is a structure by the way, which stores the value of 18. That's it. Did I skip something? Let's see the errors and make amends to it. So it says something like required by this formatting parameter. Yeah, I missed what? I missed the sort of debug mode where I have to copy this question mark from here. Get copied. Let's copy and paste. Yeah, I don't think so. I remembered. Yeah, so we get owner, and owner is a structure, but to access the method to it, like if I say print, what will this print now? So it prints nothing because this method returns nothing, whereas this method returns something. So instead of saying print, if I say, add one, it will do something like it will give me the return value and we'll be able to print it. Oh, what happened? Oh, sorry. I am really, really sorry. Still, so there's an unclosed. Oh, damn it. These are some silly mistakes, all right? Just don't mind them. Ah, and now we get nothing. How interesting. Like, how interesting is this? We are not even adding one, like, we are adding one, sorry. But instead of getting anything, we are just getting nothing. Can this be more interesting? I don't think so. Let's just remove this, run it normally. We'll get a owner of 19. That's it. If I just try printing the whole owner and passing it a value of something like 5, now what happens? Like what I did over here is instead of giving it to a mutable variable and then doing things to it, I just defined a new owner, which is structure, and given it a value of 5. All right, let's move on. So we were in traits. Where I sort of asked what the trait is and all that. Does it remember it? Does it remember what I asked? It doesn't. So let it be. So now we know this default is a trait, whereas this small default is a method for that trait, and borrowed is a structure. Implementation is the implementation of the trait with a method, and we are just returning x, which is reference of 10. And in the main function, we say something like let b is borrowed, which is the structure, and we give it a value of default. Oh no, we use the trait default, and then we do what? We say b is what, and then we print b as 10. Yeah. So b is the b, which is borrowed structure, and x as 10. So we give it a default value. If we did not, we can also give it some value from our own side. If we don't want to use a default value, we can give it a 50, a value that is 50. And now if we try printing it, we'll get a borrowed. Oh, not like this. Sorry. I am really sorry. Now borrowed, I think, does not take anything. So it'll anyways create some problem. Like borrowed does not. There are few changes that we need to make. B is borrowed, X this. Now it says what? Ah, not X equals to, it's X colon. Now what? Ah, reference, sorry. Hmm. So this is what I want to do. Like we can send any sort of reference numbers. Why we have to send a reference of numbers? Because it is accepting only reference of numbers. So yeah, not a problem. It's like not taking int 64 or int 32, like integer of 32. It is taking a reference of integer of 32. So with a lifetime of a. Lifetime doesn't matter much. Like it matters, sorry. But over here, we know lifetime is there. All right. So this can be there, but if you don't want to, give it your own value, you just want to use a default value, you can do that by reverting back to what it was. Like default, you're calling a default method which will initialize it with a default value, which is 10. That's it. Let's move on. And now we are with bounds. Oh, 3 more lefts and only 30 minutes to go. Let's finish it. So bounds, just like generic types can be bounded, lifetimes themselves generic use bounds as well. And the colon character has a slightly different meaning here, but plus is the same. Note how the following reads, like t is of lifetime a, all the references t must outlive the lifetime of first of a, and the trait, the t is again now trait plus lifetime of a. So now t must implement the trait and all references in t must outlive a. So it says the same thing but in a different style. So t is of type trait, like on dependent on trait, implements the type trait, and t must also outlive the a. That's why we use plus. Now, example below shows the above syntax in action used after keyword where. Where is it? Oh, over here. So t is of type t has a trait debug. I don't see any lifetime. Yeah, over here. T is of type debug and it also has a lifetime of a. And that's it. So let's read the whole thing. But before that, let's run it. If it runs well, it runs well. Now start reading it. We have standard FMT debug. Why is that? For this, isn't it? And like calling it like debug and all that. So to call a normal debug, we have to do this. And then we derive debug for the first structure, that is reference. Like we define a structure that is ref, which has a lifetime a, and t, which is dependent on lifetime a again, and it takes a reference of t, which is dependent on lifetime a again. So it means that t must outlive a. Now the ref contains a reference to a generic type t that has some lifetime a unknown by reference, and the t is bounded such that any references in t must outlive a. Additionally, the lifetime of reference may not exceed a. Now the generic function which prints using the debug trait. So we create a generic function which prints using debug trait. So t is there, generic t, which tells us this is a trait or generic trait, and yeah, this was called foundation, which was this one. This t is debug, this is foundation, isn't it? And now t is of type generic t, where t is debug. We can sort of explain that over here only, but we are doing it over here. It doesn't matter. This is way better for readability. That's why we used the where keyword for the bound, and then we define the bound, that is t is debug, and then we try to print it, that print t is, and then in debug mode we print the whole t that we passed in the print function. And then in print ref we do something again, but before that let's read the comment. So here a reference to the t is taken where the t implements the debug and all reference in t outlives a. In addition, the A must outlive the function also. So let's see, printf is there, A is passed, T is passed, both A and T. Instead of just T, we pass both A and T because that's how we define our foundation. All right, then we pass the reference of ampersand T, which is generic T over here as T, and then we use that T to print T. But what's important is when we are defining the foundation where using where keyword, we say it's of type debug, which is of trait debug, and it is dependent on lifetime of A. So T must not outlive A. In function main, we define X, which is 7, and then we call a ref X, which is, a reference of X, which is this structure. So inside that we pass a reference of X instead, not just 7. We passed a reference of 7. Why? Because it takes a reference of generic T. Over here it's just int 32 or int 64. Let's define it is of type int 32 so that I can say it is of type not int I32, sorry. Sometimes I mix up with C and all that. And then what we are doing is we are trying to print ref, like printing the reference of X. And then over here, yeah, it sort of took the ampersand like address, but the print just took the X, which is, already the reference of X, and just prints it out. Now we should get something interesting. That is this one. That print ref T is reference of 7 and print T is reference 7. Same thing, but print ref is bound by the lifetime of A, so it cannot outlive A, whereas this one is not so much. It's just a generic function with a debug trait in it. Now coercion, and I guess this is our third last topic. Yeah, so we have 2 more, which is static and elision, and we still have 30 minutes left. Great, we can do this. So let's read coercion and let's see if there's anything. So static is a bit lengthy. All right, static is a bit lengthy, not much. And then elision, which is short. So just static will take some time. So let's read coercion, and after that we'll take a break before static. So coercion, a longer lifetime can be coerced into a shortened one, that it works inside a scope it normally wouldn't work in. And this comes in the form of inferred coercion by the Rust compiler, and also in the form of declaring a lifetime difference. So here's how it's done. So here the Rust infers the lifetime that is as short as possible. The 2 references are then coerced to that lifetime. So we have a lifetime, depending on A. The first is, first of all, the reference of I32, which is dependent on A. Second is also dependent on A. And the result is just I32, dependent on nothing. Then we multiply first and 2 in the function multiply. That's what we do, as the name suggested. And then the second comment says this is A is coerced to be a lifetime of B. So lifetime of A is dependent on lifetime of B, and lifetime of B is passed as usual. And this does what? This reads the lifetime of A is at least as long as the lifetime of B. Here we take in an reference of ampersand A, like lifetime of A and I32, and the return is A, and in ampersand we pass lifetime of B, which is I32, as a result of coercion. So choose first. So A, which sort of says that it lives longer than B, the lifetime of B, and then we pass just B, and over here we say not longer, but A lives at least as long as B. All right, not longer, but at least as long as B. Now the first one says like ampersand A I32, and the second one, which we don't care about, is B I32. And now see this. We were not able to do that back back in the code, but now we can take this B as a lifetime and pass it to the result. But it does not live, like first lives inside this choose first, whereas the second one, which is we don't care, wildcard. But still, while returning, we say return with a lifetime of B, not with A. This is good. Why were we able to do that? Because we sort of binded lifetime of B with lifetime of A. Now we have a let main function. Inside that we have a first, which is 2, and second, which is 3. So this has longer lifetime, this has shorter lifetime. And now what we are doing is we are sending first of all the println, which is multiply first and second. So this will just print based on the longer lifetime. This will live outside of this scope. This function will do. And the println, the second one, which is choose first. So it tries choosing first, but it lives as long as the second one, which is 3. So it will die after this. And we are just printing. This is the first. So the product is 6, exactly 3 to the 6. And then this one, which is choose first, which takes A and B, returns first, which is 2. So it takes this, and yeah. What if we say something like A, will we get any errors? I don't think so. We can, but we should not. Yeah, we didn't get any errors. But now what's important is we can do with a lifetime of B also. Otherwise, we were not able to do that. Like if you want to see a real error, let's do this. Let's get a real error. Now this will give us a real error, not because of comma, but because now B does not live as long as A. So it says lifetime may not live as long. So lifetime of A is defined over here, and lifetime of B is defined over here. And it says we cannot return with lifetime of B because we are not using anything. So it says first function was supposed to return data with a lifetime of B, but it is returning the data with lifetime of A. Why? Because it is not coerced. But now if we do coerce it, coerce it to lifetime of B. Oh, let's click it. Yeah, now we coerce it to the lifetime of B like this. And now this function, this sort of would not work. And it says like, consider adding the following bound, like try coercing it. And it might work. And we did. And it will work. So because of this coercion, we sort of got the error because B was not living long enough. But now, because of A, B lives long enough. So A is at least as long as B. If B is shorter, B will expand to A. If A is shorter, A will expand to B. But they will live side by side for this function, at least. Now static. This is a static. This is long enough. We'll take a quick break, like 5 minutes. And our life is there. So So we are back and let's start from static. All right, that's where we left. And I guess this is our second last topic. And after that, we are done. Yeah, last is elision and we're done. So static. So Rust has few reversed lifetime names. One of those is static. You might encounter it in two situations. Somewhere, first of all, static what it does, it makes the lifetime gets compiled into binary. So it lives as long as the binary lives. All right. So this is what static does. So if we say hello world is a static string, static star, what does it compiles this hello world string into the binary form. So whenever we run the binary form, we have hello world. So hello world can sustain or live, or the lifetime of hello world is as long as the program lives. It's simple, but not that much, because we can't do this with every sort of string. We can't make every string sort of static and make it compile into the binary, because that will make our binary heavy, and second of all, it's not very efficient. So Rust has few reserved lifetime names, and one of those is static. You might encounter it in two situations. So first is a reference with static lifetime is this one, where the let s, so we are declaring a variable s, which has again a lifetime of static string, and the value of that is hello world. All right. And then the second static is static as a part of trait bound. So now we want a trait that lives as long as, well, as long as you know the trait lives, or the generic trait lives. So we have a function generic, and we are passing the t, which is a generic trait, and then x is of t, where the t is lifetime with a static, and what we are doing with generic doesn't matter. But what we should see is that t, which was this generic t, is of type static, so it is a static trait. Now both are related, but certainly both are related, but subtly different. And this is the common source for confusion when learning Rust. Here are some examples for each situation. So we have some examples to explain those things. Again, so we have a static num, num type, which is of type i32 and has a value of 18. So it's not a very dynamic type, static one. So make a constant with a static lifetime. So this is a constant with a static lifetime 18, and then we have a function which is core static. So returns a reference to a num where it's static and lifetime is coerced to that of the input argument, where the function coerce static is dependent on a lifetime a, and we are taking it as wildcard, which is dash, and then it is of type reference of i32 but with a lifetime of a, and return value is the same, like reference of i32 but a lifetime with a, and then we directly return the num, which is this but reference of it, so reference of num. All right, this is the coerce static. So it returns a reference to a num where it's static and lifetime is coerced to that of the input argument. So it's of if this is static, then this a lives as long as this static lives. So yeah, it also lives long life. Now in main, we do what? We create a let static string, and then inside that string, we say like I am in read only memory, and wait a second. So let static string, we store something like I am in read only memory, and yeah, it automatically gives it a type of something like this. It is automatically a type of static and str, this is automatically inferred from this declaration of variable. But yeah, this is implicit. Now we try to print the static string, the static string, and it prints automatically. But it is also living as long as the program lives. And the next thing we do is we, in another scope inside main, we create two scopes. So first one was this, the second one is this, where we sort of, declare a lifetime num, which is 9. Now it says this is a lifetime num. This is not a number, this is a lifetime number. So makes an integer to use for coerce static. So it sort of coerces it to be a static lifetime. And then coerce the num to a lifetime of lifetime num. Then we say something like coerce static, and then we coerce the static of ampersand lifetime num. So we take a reference of lifetime num and pass it to a coerce static over here, and we make it a lifetime of, well, static, which is, universal, or as long as the program lives. And then we print the coerced static, which is again the number that we passed, and now it has a type of 18. So it was 9, and now it will become 18, I guess. So coerced static becomes 18. Earlier it was 9. As soon as we say coerce a num, it becomes 18, and and gets stored in sort of coerce static. If we, instead of saying, lifetime num, we say something like 9 or 5, and we do that, we still get 18, because that's defined in this function only. So we don't get anything except for 18. We do anything. And then the print ln outside of the scope is trying to print num, that is declared exactly over here. So it prints, it is 18, number 18 is accessible because, it is everywhere. If we try printing this static string, will it be able to print outside of the scope? Let's try doing it. If it does, it means it is living as long as the program lives. If it does not, we have an error. So it is static string, but only inside a scope. Cannot find the value of static string in the scope. Why? Because it can only be found in a scope, not everywhere. But then why do we say it's a static string? So there's a little bit of confusion. Not a little bit, but most of a confusion. This makes a static number, all right. This causes any number into the static number, which is 18, all right. Now this one is sort of, a static string. Like, it is a string, but as for static, like, it does not live as long as the program lives. So I don't know, let's copy this and let's do that again. But here, instead of implicitly implying what I mean, I will say explicitly that I want it to be a type of static and str. This is what I wanted. And should it print this one? Yeah, it doesn't. Why? Because there is a error. Now there is not any sort of error. We still say not found in the scope. So scope matters even if we make it, ampersand static string. Scope matters for this one. Okay. So what can be this used for if the scope matters this much? I don't know. It is read-only memory. Well, immutables are read-only, so I don't know what it's trying to say. Immutable variables are read-only, isn't it? We can make mutable variable which is not read-only, which can be written and read as well. But immutable variables are read-only memory. So what's the difference between a normal mutable variable and a static string? The lifetime of static, and then a mutable variable. Like, what's the difference? If I say it's immutable, if I say it's mutable, then will it make any sort of error? It doesn't. So if I want, can I change this static str, which is only read only memory? Can I make it read and write only memory? Like push string something to it. Something like push, and there is star. And what I'm trying to push is C. I got I got an error, but because of semicolon. So let's make a semicolon and see if still I get an error. Yeah, it says not. Damn it. It says push string is not found in the scope. Push string where? I want to push a static string. So static. I forgot how to use this. So that's why this might happen. Static string push star C. Method not found in oh. But if I just make it a normal, method not found in ampersand str also. Uh, let's make it string. I guess, instead of just pushing string, just push the character, push C to it. I don't know what's happening. I guess my knowledge with push stir is not very good. That's why this is creating some errors. So I'll just say help me with this. Help me with this. Yeah. This code has a problem. Like I'm read-only memory are stored in read-only memory and have a ampersand static type. All right, so it doesn't have a push string. Option 1, use string. Yeah, I want to use this one, string from, something like this, and then string, and then from. Inside that, let's use this. Now this would work. Doesn't work. It does work. Option 2 is use mutable array if size is fixed. Oh damn. And third option is use a mutable static variable. Is it not mutable? It is mutable, but now it is static, static mutable. What does that mean? I have no idea. But it is of type ampersand str, not ampersand static str. Now, if I try defining that this is of type, ampersand static and then str, I will get an error. That's what I expect. I get an error. It says str is not found. So I'll make, instead of str, I'll make it string, which is a different type, string. But string cannot be sort of static, I guess. Expected says you can do this. I can also use toString, no? So instead, if I say something like this, just toString. Should I use this? Let's use it. We'll remove this later on. And just use to and then I don't know, capital, small, str, r, first of all, r, toString. Method, toString is a method and we must use it very properly. So it runs, and now this is a string. So if I say this is of type ampersand string, it works? Doesn't. What it says, expected ampersand str found string. So it is of not of type ampersand string, it is of type string. If I say it has a lifetime of static, then it works. It doesn't. So it says expected type is this, and you might have meant to write something like ampersand static string. Now this works. But to make this, we can make ampersand over here or either over here. So let's try both. First of all, let's try it over here. Yeah, we get an error. Saying what? We also should have it over here. How about that? Ampersand. Remove this mutable. Why? Why should I? Let's remove it. But if it's not mutable, how will I mutate it? Like this will create another sort of error. See? Borrows last static. So creates a temporary value while static is temporary value is freed at the end of the statement. Let's say over here, this is mutable string, then static would work. Damn it. I'm not doing this again. Let's get back and run it normally, like on one would, and cannot borrow as mutable. Oh, yeah. We cannot make change until and unless it's not mutable. So let's make it mutable. And now it should change. It works fine. I just want to see if it works without any brackets. If that's great, then I think I've achieved what I wanted to. It does work great without any brackets. So good for us. Good for us. Now if I just say push, so it will just push a character, not a string. It will just push a character, not a whole string. Doesn't it? Yeah. Pushes a C to memory. So it becomes memory C. If I say push this, so this is now two characters. So it says this will not work because there are two characters. So either erase that character or just use push string, push str. Then it doesn't work. Why? Because string uses two quotes. All of a sudden, we have to change everything. Now we are back to working. See? Yeah. Since static reference only needs to be valid for the remainder of a program. Oh shit, only 2 minutes are remaining. So I have to finish this. Otherwise, we will have to, well, end this. Since static reference only needs to be valid for the remainder of program's life, they can be created while the program is executed. Just to demonstrate, the below example uses the box leak to dynamically create a static reference. In that case, it definitely doesn't live for the entire duration, but only for the leaking point onwards. So we create a external create rand. We use a random from create. Use rand and fill, right? We are using that to fill random values. Then we say function random vector. Inside that we have a result. Inside that we are passing nothing, but then we are getting a result which is of static type. And then it says u size is 100. All right. It is of u size like unknown sized, and it is 100. Length is 100 for the vector. Then we have a let mutable RNG is equals to random thread RNG. And then we have a boxed, which is like box 0. We are filling zeros for 100 for the 100 elements in the box. And then box try fill a mutable RNG. Then we are trying to fill a mutable range, and we are saying unwrap if any errors, just exit. Then we say box leaked and boxed. This box is getting over here. All right, so from main, we say first is this, static u size of 100 random vector. And then second, this is again random vector, which is created using this u size of 100. And then assert any, that first and second. Any, I don't know. EQ, like equivalence, any, I don't know. Any, I guess negative. So it gives us a error saying, well, change few things. Not found in rand, first of all. And second, it says something like second, use rand RNG instead. Do something like this. I did not change anything, so I don't know why this doesn't work. I think I'll have to end it over here because I don't see what's happening right now. And this is straight bound. So I think I'll end it. But before that, let's see if we can see elision. So this was elision. Let's see its output. And we'll end. So elided input 3, annotated input, elided pass, annotated pass. Elision is some lifetime parameters are overwhelmingly common, and so the borrow checkers will allow you to omit them to save types and improve readability. This is known as elision. Elision exists in Rust solely because of the pattern of these patterns are common. And the following code shows a few examples of elision. And for more comprehensive description of the, see the lifetime elision in the books. All right, we are back to our books. We'll continue from, static string again. Bye-bye.